This is Two Wheelbarrows and a Place We Call Home with Josh Carroll and Brent Rollins.
All right, Mr. Brent, podcast number 2 of Two Wheelbarrows and a Place We Call Home.
Yes, sir. So first of all, we need to establish that when we're talking about workability, we're talking about fresh concrete. Because hard concrete's not workable anymore.
Well, you can't move it. I mean, depends on what you call workability. You can saw it. You can do all kinds of things to it. I mean, but when we're talking about workability in fresh concrete, we're talking about the ability to move the concrete, the movement of it, the flow, however you want to look at it, but is that movable part of it? And we all know you've seen different concrete movements. And I mean, the typical one is everybody runs a slump test.
Yeah.
And, colloquially, everybody views that as how, and I'm air quoting for people, how wet the concrete is.
Yes.
Because that gives us an indication of movement. It's really more consistency in things that we're actually checking. But, coming from my career, everybody looked at it as, well, how wet's that concrete? What do you mean? What's that slump?
Yeah, exactly.
And it's defined. And for those who don't understand what a slump test is, it's as simple as taking a cone. And those who cannot see the cone through Audible, it's a cone that you put in. It's 12 inches tall. You rod. You put in 3 equal layers by volume, not by height. Rod it. You pull it up, and you see how much that displaced center from the top of the cone slumps down. Mm-hmm. And that gives you an idea of how fluid the concrete is.
Right. So when you see a set of specification calls for 4-inch slump max on a project, then that means that it can't fall more than 4 inches in that test from the original displaced center. What happens in the real world many times when the slump is too low or the concrete's not moving the way it is going to move? What is the most common response to that from concrete contractor's perspective, would you say?
Oh, first thing I'll do is add water, but I'm going to harken back to an old finisher that I started out dealing with early in my career who would 2-gallon you to death.
Yes.
It was, give me 2 gallons, stir it up a little bit. He'd 2-gallon you that whole truck if you'd let him.
Oh, yeah.
But they want to make it as easy on themselves to work. I mean, they're out there busting their tail to get concrete down.
Yep.
Finishers by and large, they want a good product.
Yes.
But they also know they got to get it down. So, and too dry of concrete can still be detrimental to concrete in itself.
Absolutely.
So you got 2 dynamics going on. You can either be too wet or too dry. But the significance of workability is ability to get that concrete placed.
Yes.
In the form and the desired way you want to. I mean, you've been on one of those jobs where you had a lot of rebar in it, and if you were doing a 3-inch slump, that was not going to happen.
No, not at all.
And I think that was my first. Playing with self-consolidating concrete, actually.
Yes. Yeah, so workability is an indicator, from load to load, how the water might vary, let's say, but it's not giving you a water content. It's giving you a consistency. It's giving you the slump is giving you a consistency. It's giving you a way to track how things are from a quality perspective, how it's going. Now, we can get slump in many different ways other than water. Material selection is one way. Use materials that are things like more rounded or cubical aggregates are going to flow and move better than a concrete that's made with chippy, flat, and elongated aggregates. Those are going to lock up and not want to move as well. But we know that one of the oldest relationships in concrete that we know about is just simply that in general, the more water that you add to concrete, the less strength it's going to have and the less durable it's going to be. And I say in general because we know that concrete can be too dry.
Right.
Or things like certain special types of concrete may be designed with a high amount of water. But in general, for a given cement content, your water content is something that should be paid close attention to make sure you're not going over what that design water content is, so you don't end up with a concrete placement that has problems with strength or other things. There's other things that can cause strength problems, but the workability and using water to adjust your workability should be something that's carefully considered.
Right. But,
Yeah.
from a test man perspective, one thing I could look at is all my trucks coming in very consistency. So the slump was in some ways less about water
Yep.
and movement, but consistency of the batch plant. Is the batch plant having some different things going on that might be causing this change? Because if I'm getting consistent 3 and 4 inch slumps, all of a sudden I get a 7 or 8 inch slump, something's going on.
Yep.
Or if it drops back down to a 1 or 2. And that's generally when I'm picking up the phone and going, hey, Mr. QC guy, what just happened to this concrete?
Yep.
Something just changed.
I got many of those calls from you back when I was working for a concrete company and you were with a testing lab. I remember those calls. I'd get a call, and sometimes it was even more specific than that. You'd say something like, hey, Brent, you got something going on with your rock. It doesn't look right. And sure enough, I'd go out and I'd go out to some stockpiles at the plant in question, and there'd be a gradation change or a change in the way that the aggregate was being washed or something that was a problem.
Yeah.
So that's one thing early on. I know we've talked about it on videos, but early on in this podcast, I wanted to be sure to bring up that relationship between the concrete producer and the laboratories, and I don't mean covering up for each other's mistakes by any means, but I mean that if you can establish a friendship relationship, working relationship with concrete companies and laboratories working together to get that owner the final product that they're looking for, that's a very valuable tool that makes a lot of problems and a lot of finger pointing go away.
Well, at the end of the day, you're trying to get that job to be the best it can be. So, pulling that old wording that gets used a whole lot is dream work makes the team work. I mean, teamwork makes the dream work too.
There you go.
Both actually work.
Yes.
But the big thing is the more you can work together versus fighting amongst yourselves on a job site, the better that job's going to be.
Yep.
Be able to communicate what that is. I mean, but, going back to just the workability on it, I mean, I had a job that I just kind of shook my head one day. I pulled up on a job site early in my career, and they were just, forget 2 gallons. They were just about emptying every bit of the water in it. And I'm like, guys,
our trucks held 100-gallon tanks on the side of the truck. So, I mean, that's a significant amount of water in a load.
And on this job, we weren't there to control anything. It was just go make a set of cylinders, report what we had to the superintendent, and go from there. So I went and talked to the superintendent, like, hey, man, they put a lot of water in this. Do you want to do anything? He's like, nah, we're good. Just make your cylinders and get out of here. I'm like, let's not. And he actually asked me to make them before they put the water in. I'm like, absolutely not. His project manager pulled up, and he put a halt to that thought process really quick.
Sure.
But to tell you how, air quote, wet again this is he just dropped the back of the chute. And I've never seen this before or after.
Okay.
That when that concrete rolled off, it actually launched itself up in an arc. Not just came off, but arced it. And as they're placing it, they had like half-sticked come-alongs. Mm-hmm. Okay, so normal come-along with normal,
concrete rake for those
concrete rake
outside of the southeast.
You got a typical broomstick length on there, and they're about half, and that's not something you normally see because you're actually pulling concrete and moving it. And a guy was like 10, 15 feet away, and he goes, hey, I'm a little low. And the guy, all he did was he slammed his foot in the concrete, and he watched this wave right across. He goes, you good now? I'm like, oh, man, this stuff.
Oh, wow.
I don't remember what the cylinders broke at when I made them, but let's just say they did not meet design strength.
Sure.
So, sometimes the workability, just because it's what you want, is not what the job needs. So me talking to the project manager, we're trying to get that worked out. Unfortunately, by the time he got there and got involved in it, most of it was placed out. But that goes into, we didn't have a pre-construction meeting.
Yep.
So communication was just non-existent really, from the superintendent down to the test guys. He just calls up to come make cylinders. Most of the time we're talking about what that needs to look like. The finishers are there. So all that just didn't work into, so that's not a fresh concrete workability, but that's a project workability. So I'm just going to wrap that all into one. But, the other thing is you get some people who are eye checking some things. And I calibrated my eyeballs pretty good, but I was never just doing that. I always ran my slump test.
Sure.
But the first time I seen pea gravel threw me off real quick. I'm like, this stuff, there's no way this is going to meet slump.
So natural rounded 3/8 inch or so, half inch.
Very, very small rock. Normally, I was dealing with the half inch, 3/4, 1 inch rock. and I'm down to 3/8 inch. The way it worked and the way it looked was completely different. But, Mr. Brent, and all your time in ready mix,
Yes.
I mean, we know there's certain factors that can affect that workability.
Yep.
Let's talk a little bit about that from the batch plant side of things.
Sure.
What can a batch plant do, or what factors come into that can affect that workability?
All right. So the number one in my book. So we probably have concrete producers, ready mix suppliers. Probably have some concrete finishers, maybe even some GCs that are listening to the podcast. And my experience from the ready mix side of things is that workability begins to suffer or have variations. I don't mean to say suffer one way or the other, just inconsistency if you don't have a good control on your aggregate moistures. So you got stockpiles of aggregate or silos of aggregate, depending fine and coarse.
Right.
And if you at the beginning of the day, the trucks that you got coming in, bringing in your raw materials, the beginning of the day, your sand might be running 10 or 12% free moisture. And so you're taking out that 10 or 12% free moisture and putting more of that sand back in to make up for that.
Right.
And then you get about halfway through a pour, and the sand that's coming in now is only 6 or 7% free moisture. And then all of a sudden, you're holding out too much water, and the loads began to be too dry. And you guys out there probably wonder, how in the world could a concrete company ever send a load of concrete that's too dry? And the answer is, if you batch it dry enough, if it's a dry batch, obviously you're not going to have this in a central mix plant as much because they've got automatic consistency monitors on the precast. Sorry,
No, I was just going to say, there might be some people who don't understand the difference between
dry batch and central mix.
Yeah, and we can get that later. Just understand that at some point in time we will talk about dry batch versus central mixes and get in that. But
so with the dry batch truck, you've got rock and sand going into the truck on a conveyor belt that's going into the mixer truck that's on charge speed. The drum's spinning very fast. And as that rock and sand go in, you begin feathering in your cement and your supplementary cementitious materials. If you don't have enough batch water in the nose of that truck, then you can experience something called head packing, where you get dry. Think of making pancakes, and you got dry flour on the edge of the bowl, and you haven't mixed it in well. Similar thing happens where that dry material will stick to the drum, and then you've got other material that's loaded on the back of it. And when the driver goes, and then the tailwater goes in and wets up that last yard or 2 or 3 yards on the back.
right,
So the driver goes over to the rack, he's washing his chutes down, he's getting ready to take his ticket and go to the job, and he's looking in the back of the truck to verify that his slump's okay. And he sees a slump that looks like a 4 or 5, when in reality, it's a 0 at the nose of the truck. So by the time he gets to the job, the stuff's so dry it's not coming out of the truck. That's that's a way that it can be too dry. It can go the opposite way and be too wet from simply not monitoring your sand moistures or your coarse aggregate moistures the way you should. You can get loads that have too much water in them from the batch plant unintentionally. Now, in today's world, a lot of those systems are automated. So you'll have moisture meters and probes and things that continuously update your moisture and those things. But that's in my mind, of all of the workability issues that I've dealt with, hundreds or thousands of them through the years, the number one cause has been improper or insufficient sand and rock moisture monitoring. And that may seem kind of boring but it's crucial to the production of good quality concrete. Other things that can affect workability, changes in your cement and your supplementary cementitious materials can affect workability. If the grind of your cement changes, that's the number one thing with cement. And that can be seen. So cement companies produce something called a mill test certification report, or mill cert as we call it in the industry. And on that mill cert, there's going to be a Blaine number, and that Blaine number is an indication of fineness. And if that Blaine number goes up, it's getting finer and finer. And if the grind changes and the Blaine number goes up, it can take more water than it needed before, and vice versa. If the Blaine number goes down, it's going to take less water to get the same workability. So cement changes can affect workability, but thankfully it's not. It's a slow process. So in other words, it takes you a while to pull through a tanker of cement. Right. They're not going to. A cement mill is not going to switch their Blaine on you overnight without letting you know. Typically, so. Supplementary cementitious materials can affect workability in other ways, but one of the ways that they can affect it is through, and we'll get into this with the admixture discussion. Your LOI on fly ash, for instance, loss on ignition is, and I may be going a little deep here, and I don't mean to be, but LOI is giving you an indication of the carbon content of that fly ash, and if that carbon content goes up, it kills air bubbles. It pops air bubbles. And if you're popping air bubbles in exterior air and train concrete, then you will definitely see a workability change, because in general, we don't make air and train concrete with the same core sag content as interior concrete with no air. And what I mean by that is you've got more room to put rock in an exterior mix if you've got a good air content, because it's all going to work and be cohesive and be nice. But as soon as you pull that air out, all of a sudden you got a rocky mix. And I know that I have a lot of experience with rocky concrete. And in fact, one of the companies I work for is no longer in business. Was called North Georgia Ready Mix, and it had the moniker, what was it?
North Georgia Rocky Mix.
North Georgia Rocky
rock
Mix.
On top of rock is. I loved y'all's. It wasn't manufacturer sand; it was blue sand.
Yeah. I mean, it was gray. I have no idea why we called it blue, but as opposed to white sand, the natural sand. But the concrete industry is full of those little colloquialisms in various parts of the country, and various even companies will use nomenclature nobody else uses. Earlier when you said "come along." That reminded me of, not everybody in the country might know what a come along. They might be thinking of the tool used to pull an engine out of a car.
I was actually thinking that occasionally we ought to just throw a word out there and just see, let's find Dr. Google and get them on it.
That'll be fun.
But yes.
So admixtures was next on the list. You want to
start?
No, I
was going to ask you. I mean, you went into air entrainment for exterior purposes, and we're not doing air entrainment inside, and there is a difference. And we'll get into admixture a little bit different later about entrained versus entrapped. We'll deal with that. But so we know air can affect the workability.
Yes.
There's other ones out there such as a super plasticizer.
Yes.
Or just a high range or low range, medium range water reducers.
Yes.
So it's a way to reduce your water to get that workability, that movement by adding the chemical admixture.
Absolutely. And that's a conversation that I want to encourage everybody to have with your concrete supplier. And it's really super easy. Just call up your concrete dispatch office and say, hey, can I get the contact for your QC guy? And talk to the QC guy or girl about the needs for workability on a particular project.
You meant person.
I meant person. I'm learning the political correctness stuff, but I'm not good at it yet, and I apologize in advance. So let them know if you think that your crew is going to need a 6-inch slump to be able to place the concrete well, then but the specs are calling for a 4, then that's something you want to try to get taken care of ahead of time with
early on with in the middle process,
yeah,
right?
Exactly.
So you're not getting on the day of the placement and having a problem with it.
Exactly. But
most architects don't want to make that change or the structural engineer on the last minute.
Exactly. They want to know about it ahead of time, and the concrete QC guy is going to have the access to the high range water reducers or mid range water reducer that it's going to take to get you to that 6 without adding the water. The water content's still going to be for that 4 or lower, right, but the admixture is going to allow it to be chemically modified to get to the more workable concrete that you can actually do something with.
Right. So what other admixtures? I mean, we did a video once on VMA, so we'll go back through that if you want.
Yeah.
Viscosity modification.
Yeah, viscosity modifying admixtures are really good in that they are able to hold the concrete together when it wants to collapse or segregate. And what I mean by that is segregation, when we refer to it in the concrete business, is referring to the coarse aggregate going one way and the cementitious and water and sand combination going a different way. So you end up with really an ugly situation. Those viscosity modifiers hold it together, and especially are useful in things like self-consolidating concrete. When you're talking about really wet concrete, those are really good to hold it. Underwater concrete, you can virtually not do underwater concrete without a VMA.
Or you're looking at high drops.
Right.
You got that too. But
yeah, high drops is another source. Excellent point.
This is we're talking about segregation. I got a story for you.
Okay.
So many years ago, I pulled up on a job site and we were placing not pouring, concrete in a foundation. Mm-hmm. And this truck rolls back and I look at it as it comes off the chute. I'm like, there's something wrong here. It looked to be nothing but water and rock.
Yep.
The next truck, after we stopped him, we're like, bring the next truck, let's see what it is, was the sand, cement, and water.
Yep.
And the superintendent looked at me and goes, can we just mix? I was like, no, we cannot mix those together. Send it back. I mean, extreme form of segregation.
Oh, yes.
they brought it in separate trucks.
I've got another extreme source of segregation story for you. I don't remember the year, but I was working on a coal-burning power plant job, and we were doing a coal storage outdoor pad. Okay, this was probably right at 100,000 square feet of concrete that was going to go underneath coal storage. We're doing it at night because it's a huge pour. It's like 12 inches thick. 3 pump trucks running two ready mix plants, 35, 40 trucks, something like that. And all of a sudden, we hear a pump lock up. And if you've ever been on a job, when you hear a pump just lock up, it is a sickening feeling. I ran over to the pump to see what was going on and looked at the concrete. And, of course, I've got a GC who is just... He's not using language appropriate for elementary school. I will just put it that way.
So you had an elevated tone and temperature at the moment of...
Yes.
Things going awry.
Yes, and it involved a finger in my face and things like that. But to make a long story short, I had 17 loads of concrete that showed up on that job site that had no sand at all, and we were trying to pump it. Obviously, it did not want to go through the pump.
Can't imagine.
What had happened...
You know, when you wet rock, it just wet rock. It doesn't make it any more movable.
Exactly. So shut the pour down, went back to the plant, tried to figure out what was going on, and discovered that the guy who was loading trucks that night was getting an error message because his sand gate wasn't opening. And he was just hitting the override button every single time. The gate on the bin that let the sand into the scale was stuck closed and would not open. And he was just... Oh, it's okay. It's okay. You know, he's letting it go. He was not checking what he was loading. So
it's never a good thing.
Yeah, needless to say, he didn't stick around much longer after that. But there are problems that can affect workability that come from the concrete plant, the raw material stream. There are problems that affect workability that also can come from weather. And I don't even know if we have this on our outline. My iPad's died. Weather-related workability issues can also come into play, especially in extreme evaporative environments. And I'm not talking about necessarily even finishability. I'm talking about concrete that is setting up too fast, and it may be setting up unevenly, where you get a crust forming on the surface in plastic shrinkage type conditions.
Right.
It kind of gets into finishability at that point, but a very absorptive base layer. A very absorptive base layer can suck water from the concrete and can cause some issues. So there's a number of issues to think about when it comes to workability. Almost all of them, or if not all of them, are worth talking about ahead of the job with your concrete producer, with the concrete finisher. What are we going to do if the humidity is too low and the wind speed's picking up? What are we going to do when these things are a
and
challenge?
and the thing is, we do have ACI documentation for hot weather, cold weather, and curing processes that get into all that.
Yes.
And it's when you're doing your pre-construction meeting, it is good to know, hey, we're putting this on a rock base. We're going to wet this down. It is going to be 95 degrees. We know that the batch plant's going to be wetting down their aggregates to keep the temperatures cool down. There's things we can do. I've seen people ice it. We've also seen some very pretty concrete getting cooled down in other means.
Oh yeah. Yeah. I mean, there's he's referring to a liquid nitrogen pour we were on, or placement, I should say. We were on several years ago together. But so one of the things that directly affects workability is that set time that you're hinting at, and in the admixture discussion, we'd be remiss if we didn't mention the accelerators that are available to help concrete set faster in the cooler temps, but also the hydration stabilizers that are able to slow that set down. Yeah. And those hydration stabilizers are so much better than the old retarders that we had when I first broke into the business in the early 90s. The hydration stabilizers actually allow the concrete to set normally just later, whereas the old retarders, the concrete would lay there, and then it would take off like a rocket. So you could get caught, if you're busy drinking a Coke for a minute or whatever. No, that wasn't an endorsement. They're not paying us anything, but
soda,
we just call pop. We call sodas and pop Cokes in the South here. Then if you can come back to a slab that's gone, and that's a problem. So admixtures.
And for those who don't know, when we say gone, it's set up. You're not going to be able to finish anymore. It's beyond its workability from a finishing standpoint.
Exactly. So those admixtures are out there and can be used. Ice can be used. In extreme cases, the liquid nitrogen, I never in a million years thought you'd take 95-degree concrete and take it to 55 like we did on that particular project, but it was pretty impressive.
It really was.
So let's see if I can. What's our next topic? No, I mean, what's next in the outline that we're following? Bleeding. All right. We're not talking about donating blood here, right?
No, but I mean, it for those who don't understand, we're talking about bleeding. We're talking about that water that comes out of the concrete. And how does that pertain to workability? Is the more water you put in, the more bleed is going to come out of it. And, that's just something for the finishers to worry about. But there is a thing that comes out with that bleeding that we see. And in your time with Ready Mix, I know you got calls. I've seen it many times, is that mottled white look. Everybody wants that gray look, or if they pay for coloring, they want it to be a certain color, but all of a sudden they get this light gray white substance at the surface. Yeah. And that directly comes out when the bleeding process during the finishing process.
Yeah. I mean, it's basically a combination of water, cement, and fine sand. Like a 100 or 200 sieve type material that is being carried by the bleed water to the surface, and it's virtually no strength, and it's unsightly, and it can be detrimental to. If you want to bond something to the surface of concrete, you got to get that off. It creates
a bond break. It's but then it could also spall off or flake off or other things. It's latents,
and it's generally worse. Latents is a great term to get familiar with, because it is something that does get progressively worse the more extra water you put into the concrete. So the more extra water that goes in, the more of that water of convenience that's going to leave through bleeding. So here's a question for you, Josh. Can concrete bleed even if you don't see that bleed water on the surface?
Yes.
Okay.
Yes. And that's going to get into another topic we're going to talk about later, but that comes into extreme evaporation.
Okay.
And there is, like I said, I reiterated to hot weather, cold weather, and the curing documentation out of ACI that gets into initial and intermediate curing for that reason, or other things you can help to do that, such as evaporation retarders. That you can put on it to help slow that bleed from evaporating out as fast as it can be. And it also sometimes can mess with finishers who think the bleed's gone and they start working that surface in, and they lock that bleed water, which creates other issues.
Yes.
So that's just a quick little ditty about workability.
Yeah. So I think it's a pretty. That's a pretty good rundown of workability. I can't think of anything that we've missed other than maybe if you guys think of something we've missed, comment or send us a message, and we'll cover it in more detail later. But for the most part, I believe we've covered the topic pretty well. I will say that eyeballing slump is something that you brought it up earlier. Eyeballing slump at the back of a truck or coming down a chute is a skill, but make sure your eyeballs are calibrated by running slump tests.
Don't do it.
Yeah.
Just run the slump test. It takes 3 minutes.
Yeah. Well, coming from the ready mix industry and knowing that people are going to be eyeballing slumps, I'm saying that your eyeballs might not be what somebody else's is, so keep an eye out for that.
Consistency.
Yeah, consistency. Thank you so much for joining us today. I hope you've enjoyed this as much as we have. I hope you enjoy our stories. Be sure to send us a message via the website, concreteprotection.com, or here on your whichever outlet you're receiving this podcast, and shoot us comments, questions, complaints, queries, theories, or observations.
Thank you.
Thanks for joining us for Two Wheelbarrows and a Place We Call Home with Josh Carroll and Brent Rollins.